think that's what it was.
Okay, does somebody have it?
I don't
Yeah,
have.
it was negative y.
Yeah, it was negative.
But then we, oh, the whole thing's negative? Like here?
Mhm.
Okay, alright. Okay, so to find the tangent line at that point, you want to find the slope by using your formula here where y is going to be that value of y and x is going to be the value of x you were given. We can kind of try to clean it up just for the sake of doing the algebra, but I should probably go get, because I think this is my second black marker that's running kind of out. Okay, in terms of here, I mean, 1 to any power is 1. Here, this is 3 to the 3/2 power. 3 times the square root of 3 is 3 times 3 to the 1/2. And 3 to the 1 plus 1/2 is 3 to the 3/2. 1 1/2 is 3/2. So if we raise that to the 1/3 power, and properties of exponents tell us to multiply, right?
Mhm.
We'll just end up with
Negative 3 to the
negative 3 to the 1/2 power, which is square root of 3, so. Yeah, so the, just double check. Okay, so that's our slope, and that cleaned up pretty well. I think it was worthwhile to leave it in exact form than to jump to the conclusion we had to write it in decimal form. All right, so that is our slope. So my line is y equals mx plus b. The line, tangent line, goes through that same point. It's tangent at that point. So y is 1 when x is negative 3 times the square root of 3. And my square roots cancel. So I'll move the so 4 is b. And so my line ends up being positive 1 over the square root of 3 times x plus 4. And you can leave it like that. If you rationalize the denominator, if you feel like rationalizing denominators, multiplying top and bottom by square root of 3 over square root of 3 gives me square root of 3 over 3. I personally do not care if denominators are rationalized. I hope people at least recognize what's been done to go from one to the other, but I personally don't find it easier to look at this than to look at that. So don't necessarily worry about it. And then it was asking us to graph. So we'll kind of just do it by hand, since that's what you guys have, and you don't have Mathematica in front of you at the moment. Are people caught up with getting the line? I'll leave the notes up there for a moment. Okay, so my point was negative 3 times square root of 3. So let's estimate what that is. Negative 3 times square root of 3 is negative 5.2 basically, and then the y was 1. So here's y equals 1, so it's supposed to be on the curve. And there's 1, 2, 3, 4, 5, so a little bit past 5. So there's my point. And so we're hoping that our line ends up being kind of tangent. So I sort of drew it in tangent. We can kind of test it from the slope and my y-intercept. So if I keep drawing, like my y-intercept is supposed to be 4, okay? So
Isn't that line supposed to be on the other side?
Oh, yeah, 'cause
Going-
it's
going-
negative. No, yeah, you're
and-
right.
and
Our X was negative, yes.
Going positive,
Um,
because the slope's positive.
Well, right, yes, and also our X coordinate was
Yeah.
negative. So,
You,
is that?
that's one, there's two little lines there, then you
Yeah,
have one.
Yeah, okay, 1, 2,
Yep.
3, 4, 5, a little bit past 5, and 1. Okay, so that's 1 point. And then 1, 2, 3, 4 should be the other point. And then kind of testing the slope, 1 over the square root of 3 is 0.577, so every time I move over 1, I should go down a little bit more than a half, and it looks like, or sorry, I'm going backwards. If I go from here to here, I'm going backwards, so -1, I should go down a little bit more than a half, and I don't know, I think from my little shaky drawing, it seems like it's matching that, okay. Otherwise, on your calculator, you'd have to figure out how to rewrite the equation just for this side of the graph, and then graph your line, and we could do that. I guess, let's see. The original problem was it y to the 2/3? Yeah, I mean, if you were wanting, some of these you're not gonna be able to do unless you're using some software like Mathematica. So technically, when we undo that power, I'm raising it to the 3/2 power, so I'm taking this and I'm cubing it, and then I'm taking the square root, but then there'd be, to get the top and the bottom, you would have a plus and a minus. So let's just see what that looks like on our calculator. But you know what, this might not be a bad little place for me to introduce